Good morning, good morning. Let's begin. So, still terrain. And as always on Monday morning, I just need to start the day off by checking where I left things this Friday. And good morning, Harukanan. Hope you had a nice weekend. So, if I remember correctly, before I click start here, I think we left it off at a pretty rough state, I would say. Because we noticed that the patch handling of the terrain wasn't really fully implemented. It was implemented, but I overlooked a couple of things. And it got noticed at the end of last stream where we got terraforming working. So that is probably what we will be working on today, getting the patch handling in place. But it's not all bad, because I think we have the solution. So let's just check if we have it in a runnable state and if we can double check some of the issues we're having. Yes, so we can see that we currently have the correct heights at the edges, and I think it should is it E for terraforming? Let's see here. I want to terraform right at the edge like that. Yes. So does it actually... Yeah, we have a problem here. So we need to sync the patches, and we also have one other problem. Maybe it's kind of visible on stream, but we can see here that there's a small difference between the normals at the edges, and I do know why. I think. What's up, Cooler SK? Yeah, it's not the prettiest terrain, but okay, so first of all, let's take a look at what we did last thing on Friday. Was actually something good. So previously I created the terrain patches with a size of subdivision, or actually with a size of, let's see here. Here we create the patches. Here we create the actual meshes. And previously we created a mesh with a resolution +1 as dimensions. So resolution +1 times resolution +1 was the number of vertices. The problem with that was that we were a little bit out of sync with the height map. So the height map had a resolution of resolution times resolution. The actual mesh had a resolution of +1 in each dimension. So we actually fixed that. I think that was the last thing we did. So now the resolution of the mesh and the resolution of the height map matches. What that means is that if we have this patch and this patch, let me just try and visualize the different patches a little bit better as well. And then I want, yeah, we'll have a 2-line thick here, it's okay. So each red square here is one patch, and here we have the height map for this patch. So previously we created the mesh in such a way that the vertices were located here. And here, so for each line and up to here. I still wonder if that's a good approach or not. We'll keep that in mind. But at the end of Friday's stream, we ended it so that we have the vertices are located here in the middle of each pixels, basically. But in the game world, it's also, the patches are also located in such a way that this row for the right patch and this row for this patch are located in at the same world position. So this column and this column actually represent the same vertices, but they are duplicated, one so that each patch has their own vertices. So that's one thing that we need to fix. Like, we always need to keep these height maps synced. So the value here for this height map should always be the same as this one. But what that also means is that when we calculate the normals currently, so when we calculate a normal for this vertex, we take this value, this value, this value, and this value, and I think we take this value and this value as well. We do it by connected vertices. But with the current implementation, so when we try to get this value, for instance, and this value, we go one step to the right for this one, and then we notice that it's outside of this patch. So then we ask the neighboring patch for its value here. But since this one and this one should represent the same values, we get a little bit of a problem there. That means that we take this value twice and this value twice, and we don't want to do that. So instead, when we ask a neighboring patch for their values, we should actually do one step inwards as well. So when we calculate the normal for this one, we want this value, this value, this value, and then we want this value and this value. And that's an easy fix. That's just when we wrap the coordinates, we just jump over the 0 indices and the resolution -1 indices. And that is the first thing we can fix today. Like, that's just an easy way to fix, won't require, it will require one additional arithmetic operation, but that's cheap, so it's okay. The hard part today is going to make this column and this column sync. And what that means is that we don't need repeatable, like we don't initially need repeatable height maps, because we will fix it in code. We will like like in some way we will make them match, basically. So that's the two problems today. So let's put that into the issue, and I guess I would like to have this as an image as well, I think. So let's do, I want to do, let's see here. Oh yeah, then I want to invert. Okay, just make it a little bit clearer. And now let's go. Probably want to upload this one to Git as well. We'll see. So for instance, if we fill up this height map, if we take the second height map here, and let's say that we have, so here we have some height differences, but on this side we just have entirely flat ground. But let's go with, I don't know, 100. Oops, just don't make it pure black. Okay, so we have these two different height maps. The thing here then is that we need to match this column and this column. So the height maps should actually look something like, okay. After we have made the seams work, we should have a height maps that looks like this. So this column exactly the same as this column, and the same goes for this one, should be equal to the row of the neighboring patch here, and so on and so on. So that's going to be the big question today, how to fix that. Okay, but as for the normals, I think we can start with the normals first of all, to make it so that, where do we have the patches? Here, to make these match a little bit better. And also something to keep in mind, so when we want to sync this pixel of each patch, so the corner pixels, we're gonna have to ask the 3 neighboring patches of their value. But I think it's okay. So right now when we do, we have a get terrain patch that gets a terrain patch based on resolution. This one is, we don't need to do any changes here, but when we do get index wrapped, so the idea is here, if x is equal to resolution or bigger, then we subtract resolution. If it's less than 0, then we just add resolution. But when we subtract here, we want to do one step more. So right now the current resolution, when we go to the right from this pixel, leaves us with this pixel value. But we actually want this one. So here we want to do minus resolution do we want to take -1 here actually? Let's see. So if this one is resolution currently, we take minus resolution, so it becomes 0, and we get -1. The question is how exactly this one works. So let's do so we want xwrap to be equal to minus resolution, so we get to 0, but we want one step further. And over here we want, so we're below 0, we want plus resolution -1. That's pretty much what we want here as well. And that should fix the normal calculations, because when we calculate the normals, we do it down here, and we do get index wrapped, j plus 1, and so on. And yeah, so this was the current resolution to, let's see here, yeah, to match the corners. And we can see here that we actually don't match the height maps, we just match the vertex height. And I'm pretty sure we want to fix that as well. We just want to sync the height maps and not have to worry about it here. I think that's the idea. So let's see if the normals are getting calculated the correct way right now. The only problem, I think we're getting correct normals, but where are we? It's hard to see when we have a little bit of a gap. So let's see here. Yeah, and then we don't want to do this. No, we don't. So let's do let's remove these and take current here. So we have a bigger height difference now, of course, but the normals seems to be the same, I think. Would be easier to check this if we didn't have a height difference. Okay, so initially making the height maps sync should be pretty easy. So when we do, let's see here, terrain base, what we do first is we create the patches, set the position of them, and let's see, do we have, here we create a new terrain patch, we set terrain data here, and then we also set the neighboring here. And then we call generate here. We do it with a check like this. It's rough. Rordy Pants, thank you so much for follow, appreciate it. So how do we want to do this? Like, making the height maps sync, we could either just don't handle it on startup and just assume that our height maps are synced from the get-go, but I would like to do it in code actually. One less thing to keep track of in this setup. And like in the set neighbor method, that's when we set, so this terrain patch, your neighbor to the left is this patch, and yeah, the terrain patch to the left, your neighbor to the right, is this patch. Actually, what I see here, so this would actually, it should be possible to, yeah, this terrain patch exists, this terrain patch exists, so we should be able to sync them in the set neighbor method. The way it's done here is, though, that we let the terrain base set up both patches neighboring. I wonder though if we will just call this method, and within this method we also set I am a little bit worried here. Let's see. Okay, so this is one approach to this problem. So if we sync the height maps at instantiation, at creation, then we can choose to implement the Terraform in such a way that the height maps keep being synced. And I think that is the best approach. So if we just sync them on startup and we implement the Terraform in a specific way, we don't need to keep track of the syncing of height maps from there onwards from that point. We just need to make sure that the terraforming, like the terraforming for the overlapping height maps, are always executed the same. And that would probably be the best approach, actually. So then the question is, do we want to sync the height maps? Do we want to leave the syncing of height maps between terrain patches to terrain base? That feels like an okay way to do it. So that is, after we have set up the neighbors here, we also call a function something like sync height maps for patches, and then we patch 1, patch 2, and then we let this method handle it. Because if we take a look at terrain patch, we have a private terrain data here. So the terrain data is actually private for each patch, but we have functions here making it possible to fetch those values. So we can get the information, but I don't think we can set the information. So that is something we would have to make visible for outside classes. I wonder if that is something I want to do. Or let's do the syncing of height maps here, and yeah, I'm pretty sure there's a lot of questions that need answers by doing this, but I'm pretty sure this is where I want to sync it. And when we send, we need to add coordinates here as well. So like we need to tell this method needs to know, like, is it the left edge that needs syncing? Is it the right edge? And so on and so on. So the idea is, once again, let's jump back to this nice image. So when we create this patch, we say your neighbor to the left is this one, and then we want to do the syncing. So then we need to fetch this value and average them. I think that's the way we're gonna do it. The problem becomes when we want to sync this and this. So what happens if we do this approach? So we do it sequential. So we're at this patch and we say this is your left neighbor, so we sync this row. Later on in the instantiation phase, we add this patch down here, and we say your parent to the upper left is this one, sync your height maps. And then we get this one and this one. So we have previously averaged these two, so then we take the average value of that and add this value and take the average of those, which means that these two will only, the height value here, these two will only add 25% each to the eventual height value here, while this one will add 0.5, which means that this one is weighted towards this one. This height map, and that's something we want to avoid. So i.e., like the values for this value, for instance, will depend on two height maps. The value for this, okay, the edge values will depend on the height value of two patches. The corner values will depend on height values of 4 height maps. And this is a pretty good argument against doing it here. So the first for loop, we would probably set it all up. And then do the neighboring after the fact. But, okay. So here's another approach to this whole problem. What about having, so on startup and on end, we have a height map describing the full terrain. And so on startup, you slice up that, you load that height map from memory, you slice it up and disperse it between the patches. This means that you don't need to do some additional setup when it comes to syncing the height maps. Depends on how we do the slicing. But that also means that that full height map will be, it will have some weird dimensions. It won't have the power of 2 dimensions. And also, if we want to support extremely big terrain, like right now I'm thinking about not. Like the garden will have a max size that won't be extremely large, so we will be looking at a 4K or 8K texture. The terrain patches need to communicate initially to do, let's see, initially to do height map syncing, but eventually for things, and eventually also for things like sharing navigation data to entity, calculating and recalculating normals. And let's see. I think this is the current approach we have, but we don't do this. Yeah, so what one could do is we do this, and then here we add like syncing of height maps, because you would basically only need to loop through every even terrain patch in both directions. But our subdivision approach makes it so that we always have an even currently always have an even number of terrain patches, basically. Do I want to fix this so we always have an uneven amount of terrain patches? Or odd? Be to sync height maps at start. And then implement terraforming in such a way that what is the word I'm looking for, that holds, or like that adheres to or in such a way that never breaks. Yeah, if we could make this work, it would be amazing. But the problem still exists of doing the initial syncing. What do we have here? We have... Oh yeah, right now as well, we just do terrain data. Yeah, we just have one texture 2D, which we feed to each patch. That won't be the case later on. positive variable, awesome indeed. What kind of creature collecting game? I have a YouTube video about it, but I don't know if you have played Viva Pinata. But more similar to Viva Pinata and Chao Garden than Pokemon, for instance. I could make this method. Okay, is there something we can do to avoid... Like averaging the edges right here works if we would put the logic within this method. Averaging the corners, however, we have the weight problem. But let's see here. One sec, just gonna pour a new cup of coffee. Decisions. Fuck, do I want to do it like this? Yeah, let's just do it like this and see what we get. So, or how rough it eventually looks. Private void sync height maps for patches. And within here we're also gonna have to define let's see here, terrain patch 1. Let's go, yeah. But we need to send in some additional information as well. We need to send in the direction, I think. And how can we do this in a nice way? And we're also going to do this in a I'm going to start by doing this in a very unoptimized way, but I'm okay with that. So do I want to send in patch 1 indices and patch 2 indices? Could use ranges, which currently only support float. Positive variable, how long have you been working on this? I think I released my first video about it 3 years ago, but hasn't been too active initially. I would love to be able to give you an absolute hour number, you know? Although, let's see here. Can we do something with... When was the last time you worked on it? I've been working on it quite actively this whole year, actually. So Friday, last week. Yeah, I think this is the way we're gonna do it, but like what we need to keep in mind is that the corner values need to be averaged out between 4 pixels, so we need an average value or average multiplier of 0.25, while for just edge pixels we need an average value of 0.5. And then the question is just how we want to solve the varying for loops, because we're going to have some for loops that goes between 0 and resolution in the X direction. We're going to have some that loops between 0 and resolution in the Y direction instead. So you could have do wonder, maybe it's better to do it within here actually. But then that leaves us with like it's only one of these that should handle it. So that is because if we take a look at this method, here we have the neighboring and we also have the direction. Bad naming, but it's okay. So what you could have here is something like, so for this one we do average height maps, or actually recalculate height map values, and then we do dot copy height map values. But once again, will that work for corners? Yeah, I think so. I think to actually implement this is quite straightforward, but implementing it in a nice way, that's the hard part. like depending on what these values are, these values will decide which edge we're working with. So it's basically, let's just see how the logic looks. So int it would look something like this. Let's see here. Xmin if x offset is equal to -1, then we do zero if it is -1. But then again, like it's 0 for this patch, but it's going to be resolution for the neighboring patch. So that's something we need to keep in mind. We're going to work with different indices. So a lot of variables set up here. Maybe there's no other way around it. Okay, let's see here what variables we need. We need xmin, but we need xmin this. We need int xmax this. We need int xmin neighbor, xmax neighbor. And then we also need these for y, I think. And just this is very, it's rough, but if x offset is equal to -1. Let's just implement it this way, make it work, and then we can check else. Check if it's possible to clean it up or make it in a prettier way. Down the road. Basically, if x offset is -1, that means that we're setting the left neighbor, right? So xmin this is 0 in that case, and xmax this is also equal to 0, I think. Xmin neighbor is equal to, what is its resolution? -1, I think. Yeah, we're gonna start by doing, so xmin this is equal to 0 to resolution -1. Yeah, I think we can do it like this. So the default is this, then we're gonna alter it based on the directions. Unnecessary, yeah, whatever. So what we can do here is okay, if it's -1, then we do x max this is equal to x min this, and actually no, actually so if it's to the left for this one, we want to do so many different cases. We pretty much have 8 different cases. This is just a weird way of doing it. Actually, you could, yeah, maybe we should implement it as I'm gonna leave this one real quick. I wonder if the cleaner solution is to do it here. And I'm wondering if we want to do if we want more specific methods than this, like sync column, sync row, and sync corner. What's up, Skulltag? Game finished yet? No. We're a tiny bit closer to the finished state compared to last Friday at least. Because if we do it here we full well know which direction such we want to sync in, so we can just hard code it here pretty much. So we could do stuck on something. Yeah, let's put it this way. So right now we're trying to sync height maps between patches, and like it's pretty straightforward what we need to do. It's just that we want to do it in a prettier way. So for instance, when we add the neighbor, when we make these two neighbors, then we want to sync the left start column for this one with the, or we want to sync the leftmost column of this height map with the rightmost column of this height map. And I think we're gonna do it like, let's see here. Yeah, let's do it like this. Get, let's see here then. Public. Right, yeah, I've been there. It usually ends with 8 if statements. Yeah, that's pretty much what we've been doing this morning, trying to get implemented in a nice way to avoid an if statement like that. But yeah, I'm thinking of doing it like this for now. Void sync, or actually recalculate average exactly like the, and you also have the problem. So for edges you want to average on 2 values, right? So an edge has 1 neighbor value, but corners, they have 3 neighboring values, so you want to average 0.25. But let's see here. I'm thinking of creating a method that is like something like this. Let's see. Yeah, we're gonna do it like this. Recalculate or alter height map column based on neighbor, or based on neighbor. And then we Weight averaging, isn't this about chink edges being synced? Yeah, so pretty much what we have is, so these are our two patches we have, denoted by the white squares. So this is the height map for the left patch, this is the height map for the right patch. We want this column and this column to be the same in the height map. So they are pretty much going to represent the same values, because the vertices for these squares are located exactly because they overlap. So let's say that we have two from the instantiation. For some reason we have height maps that differs. Then we want this pixel and this pixel to be the same value. So we need to add whatever value we have here with whatever value we have here and divide by 2. So we're gonna average them out. And we're just gonna do this when we instantiate the terrain, because then we're gonna, yeah, say it again. Because then when we terraform it, we're gonna terraform it in such a way that we always terraform it in the same way. Use compute shaders. For like the thought crossed my mind, it did. They have a little something that prevents this issue. I'm intrigued. Feel free to share any information. Jeannie, thank you so much for the follow. Appreciate it. Like, the idea is that if we implement the terraforming in a correct way, terraforming will keep the height maps synced. So this is not anything we need to care about other than when we instantiate the terrain. And to be honest, I don't even think we need to care about it then. Let's see, because you can generate the height texture in the shader, which is done based on X and Y coordinates. So if you generate, oh yeah, so when you generate the height maps, if you use the same Perlin noise, so if you use the same algorithm to generate the height maps, you will basically have, when you generate the value for the height map here, you will have the same seed coordinates as this one, so you will generate the same value. Yeah, okay, let me put it this way. Maybe I'm sitting here trying to solve a problem that is not a problem at all. Let me start from the beginning. So when I sat down and tried to define what I want to gain and how I want to use the terrain in my game, I defined it maybe a bit too loosely. So maybe, yeah, that's on me. Bad planning. I'm not famous for my good planning. So in the initial vertical slice of this game, what we will feature in the form of terrain is basically this. The player will be given a garden. That garden will rely on this terrain system. The initial look of the garden will not be procedurally generated, but rather defined by me. So this is like flag number 1. I have full control of how the terrain should look here, i.e. I could make the height maps sync at this state, and we don't have to worry about it in the game. But then I have this idea, like I have a different portion of the game that won't be feature the garden, but this is for like the future, and this is where we start where we have to take into account that the terrain might be procedurally generated. So that moves the problem of syncing not from me setting up the initial height maps, but to the procedural generation algorithm. So depending on how we build that generation, we might build it in such a way, as you mentioned, that we don't need to sync these, because the procedural generation might do it for us. Like the only case where we would need, and I'm gonna assume that I do the correct setup, so the edges are synced, and we develop the procedural generation in such a way that the edges are synced. So in that case, or in that scenario, the only way for the terrain patches to be unsynced would be if we would like generate each patch with a randomized manual made terrain patch. So I'm rambling a lot here, but what I'm trying to get to is that this might not be a problem at all, and we might not even need to handle this, to be honest. Yeah. Okay, let's do it this way. Yeah, maybe this was just a little bit of a time sink. So let's go back. Let's remove this one. So right now, let's take a look at how it looks in game. $93. Do we have a problem here? Skulltag. Yeah, I just want to say thank you, Skulltag, by the way. You might have steered me in the correct direction here. Can I ask how the height maps are generated? So, right now, we just have a set of test height maps, and those were generated in GIMP, and I was about to get to that point, so we're gonna see. But give me 1 sec, I'm just gonna go fetch a cup of coffee real quick, and then we can get to it. Okay, back. So I think the problem is that we put too much weight on how they are generated. Like, let's see here. Currently the generation method has been something like this. We have just worked with like temporary test height maps. So in GIMP we have just done render clouds, difference clouds, and we have made them tileable. Yeah, but look at this. We're gonna get to it. They are tileable. The problem is, though, that can I get... can we show grid? And what do we... 128 and 128. tileable here means configure grid. Okay, we're at 128 here. Okay, maybe this one wasn't the best. Let's go with, I just want to show this, so 32 times 32 maybe. And then we do let's zoom in. And tileable. Okay, we still have those colors, but whatever. So let me show you. Okay. The problem with tileable generate, I guess this is like standard how you do tileable textures, but tileable here means like this value and this value don't have to be the same, but the difference should be tileable, if you know what I mean. So you have a, yeah, exactly. But with the way we have implemented our terrains, like, it's not our, but the problem is then when you have a neighboring tile here which generates a vertex based on this value, that value, like the height of that doesn't match the height of this one. The difference makes it look nice, like the difference is good, but the actual value, yeah, you get it. And that's why, so even though we have tileable textures, we get a gap. But so what we could do is, let me try this. What we could do is, let's see. Like, we want to make them tileable in a little bit of a different way. We want to make them tileable such that this value is the same as this value. But okay. I actually think, yeah, initially the terrain size was 129 vertices, so it was actually one more than the height map, but last Friday we reversed that decision. So right now the terrain mesh, the number of vertices matches the number of pixels of the height map. So it's a question of, do you want to make the vertices sync or do you want to make the height maps sync? And I think I want to make the height maps sync, actually. I think that's going to make the, if the height maps sync, we don't need to worry about it when we terraform in a way that we would yeah, because it comes down to, do you want the vertices making up the mesh to be located in the middle of each pixel, which we currently have, which I think is the best way, or do you want to make the vertices be located at the junction of each pixel? So do you want the vertices to be located at each intersection, or do you want the pixels to be located in the middle of each pixel? I mean, the easiest way is to just generate your own Perlin noise maps. I could probably do that and make the edges the same. Yeah, so what we could do is, fuck it, yeah, let's do it. We're gonna rely on Unity Perlin noise and get it to work. Oh, what's up, by the way, I missed YouTube chat. What's up, Derek? Still working on terrain manipulation. Yes, we do. And what's up, Fabic? And Fabic, don't you only need to sync them at game start? Yes. And yeah, I like the middle for sure as well. Okay, so this is what we're gonna do. We have a nice approach here. We don't need, when we generate the Perlin noise, that's when we generate the Perlin noise at game start. That's the only time we need to worry about syncing the height maps. And if we generate them in the correct way ourselves, we don't even need to worry about it. That's the approach we're gonna take. So when we generate the height map for this patch at this point, we're gonna use the same coordinates as when we generate this point for the neighboring terrain patch. There we have it. Hadouken, if I may suggest, use fast noise light. Is that a third party? I'm afraid of third party. We're gonna go. I think we're gonna use Unity Mathematics package. We have used this one previously for the grass shader, and yeah, maybe it's not as quick as fast noise light. I mean, fast noise light has it fast in the name, but you know, like, I tend to like to rely on first party stuff more than third party, but I appreciate the tip. I'm gonna write it down and we might look into it in the future. It is one CS file. Oh, that's pretty nice. What was it? Fast noise light. Like, once again, depending on how we will use this, we might want a quicker solution. But with the current approach, if we're just going to generate it at the start, we can for now rely on this one, I think. This one, by the way, I just need to mention this. Unity.mathematics is one of those packages where I was extremely happy to read about it. Like, this is what I've been looking for a while, and you also have like shader-like variables. But the documentation here is, I don't know. And Fabic, fuck it, write your own. Ooh, that has crossed my mind multiple times. Like, mostly because I do wanna learn more about procedural noise. But yeah. Ooh, they have it on GitHub as well. Let's see. This is an example. Actually, let's do fast noise light. Let's start it. Simplex noise, cellular, Perlin. I don't know, value noise. Oh, noise gen is not that hard, but it has been done a million times. Yeah, reinventing the wheels. But this is one thing that I've thought about multiple times. Like Perlin noise and Voronoi noise, those are, and simplex noise as well. When people talk about procedural noise used for procedural textures or procedural generation, these are always the noises that gets mentioned. And doesn't it exist more noises than these? Because, I mean, if you want to generate a terrain and you use these noises, like if you have dabbled with them a lot, you can always notice when like Perlin noise has been used, for instance. Whirly noise, yeah, I've heard that one as well. But isn't that... that's Voronoi noise as well, yeah. But for instance, so one of the reasons I would like to dabble in learning about noise generation algorithms a bit more is to learn, like, extend it. Like, if I would generate... I've had this dream for a long time to generate a nice, lush Swedish forest. So generate a procedural forest with a lot of stones and small rivers and whatnot. And one approach would definitely be to just rely on whirly noise or Voronoi noise and Perlin noise and just stack them in different ways. But there must exist, like, you should be able to come up with your own noise algorithm better suited for your use. But yeah, whatever. You can always use octaves for more generation. Yeah, this is a big octave. I don't even know where to start that. Procedural generation. Oh, I do want to dive into this, I do. Twitch noise, I love the idea of that. Generate landscapes based on Twitch chat. Yeah. Wow, that is actually a very nice idea. Like, that's a Twitch game I would like to see. So Twitch chat integration, and you generate a procedural landscape based on Twitch chat. Wow. Like Twitch plays Pokemon, but Twitch generates landscapes. You have Octave implementation in the code I sent you. Yeah, I will double check that later on, Fabic, and keep octaves in mind. Ooh, this is like, all of this is very interesting, but we're gonna step back a little bit and generate the okay, so we're gonna do this terrain patch. Here we have create new, and here we send in, or actually we have we have a method called set terrain data. Maybe we should create a function, public void generate terrain data. Or actually, terrain data is equal to new terrain data container. Let's do terrain data container. Let's create it's like 7 lines. Yeah, I'm gonna look into it later, Fabic. And might get back to you with some questions. But, so what I want to do now is, like, we have relied on terrain data container getting a terrain texture 2D. So what I think I'm going to do here actually is Instantiate data. Here we instantiate the texture. I think I want to do it like this. We're going to keep this one, and we're going to redo this one. So this constructor is just going to create a new texture. This constructor creates a new texture, but also sets that texture to be equal to this texture. This constructor is going to create the texture and then generate its own texture, basically. No problem, sir. Just saying octaves are very simple and you will have no problem with understanding and implementing it. I appreciate the kind words. And hopefully that will be the case. But what we can do now is... yes, we change this one. We do this, and we do this height range is equal to height range. And then here we do to do implement procedural texture generation. Yeah, we're gonna do it in an extremely unoptimized way to start, I think. Or we could do... Actually, let's see here. We have generators, gradient texture generator, Perlin noise texture generator. We can rely on this one, I think. With, yeah, we can. So this one uses mathematics. And we use this one to generate Perlin noise for the grass. And let's see here. And that's why it looks like it does. But yeah, we will get the same textures here. Yeah, so what we generate this one with here is get periodic Perlin noise value. When we generate it for our terrain, we don't want a periodic Perlin noise value. Okay, so let's... What a mess this one is. Why did I do it this way? Perlin noise coordinates, channel coordinates. Oh yeah, it's done to work better with the Unity editor. And for changing it a lot. Yeah, okay, so I guess what we want to do is origin and we have value bounds here as well. Yeah, I wanted to support different offsets per channel as well. These are good. Okay, so I think I'm gonna rely on this one, and these are good. We're gonna get a lot of garbage, but yes, Fabric, write it, make it work, improve. Okay, so write it, make it work, and then improve. So we're gonna rely on this one, generate a lot of garbage, but yeah. So Perlin noise coordinates is used per channel coordinates here. Okay, so for now we're just gonna create a constructor here. Perlin noise texture generator, and what we want to take is width, height, default texture color black, wrap mode clamp. I think we want to send in a wrap mode as clamp is good. Something like this. This dot width. We need to instantiate this one as well. So by default we just do channel coordinates equal to new fuck, am I gonna have to do repeat? Is this how we want to do it? So is this link once again? Yeah. Repeat. Can we do new Perlin noise core? And number of times as well. We want to do it. Count is the second one, so we do 4 and then 2 array. So we create a Perlin noise texture generator, and for each channel we just do Perlin noise coordinates. And then when we fetch that noise texture, that is when we generate it. I know it's, so every time we fetch it, we regenerate it, but this was done to better work with when we were implementing the grass shader. I wanted to be able to quickly change the values and have it update in real time. That is the reason because of this. I just felt the need to defend myself or defend this code. And of course, then we have get Perlin noise value, get periodic Perlin noise value. So we want to do in fact, do I want to have methods called generate texture periodic and generate texture non-periodic? And then we do so the default previously was periodic, but so Perlin noise texture generator bool periodic. And then we do so generate texture. Like this, and the only difference we have is here. Actually, we can do this in a better way. Let's do it like this. Actually, let's move back a step. Do it here. And can we do it with wonder if we can do something like and then we do what is it, action or whatever is, what is it called? Like on creation of Perlin noise coordinates, I want to have a function reference here, and when we create this one, we set that function to either be this one or this one. Action, yeah, that's how I want to do it, but what is it? So action, return, and what it takes. Or yeah. So I should do what is it? Private func float, float, float. And then get Perlin noise value, then we just do Perlin noise function UV. And that should have fixed everything here. Previously we did, so if we create this, we have periodic true here, and something like this. And then we can rely on generate textures. So when we get periodic, here we just want to do get Perlin noise value. So depending on how this one is set up, we either do periodic or non-periodic. That should do it. So terrain data container then. So when we create it here, when we just send in a height range with height range, enjoy that breakfast fabric if you're still here. So here we feed the texture 2D. Here we don't, we generate it ourselves. So basically what we need to do then is Perlin noise texture generator, and we send in with height false, and then we do set terrain data Perlin noise texture generator dot noise texture, and that should be it. And when it comes to garbage here, first of all we create this one temporarily. This one creates 4 Perlin noise texture coordinates temporarily, and then we set terrain data here, or we call set terrain data. And what we do here is, yeah, we have a temp data container, we do some graphic splits. Yeah, we do it in a very unoptimized way here, but I'm okay with that. So what we should be able to do now when we have a height map generation here, we can go back to terrain base, and this is where we call set terrain data here. Do I need to set terrain data? Set terrain data just does this. And then we rely on this method instead of this. Skulltag, I need to get a bunch of things working through UI, and it's so boring. Not a big fan of UI programming. But I do partially agree that I think the classical way of doing UI in Unity with images and stuff, that's quite boring. But when one start experimenting with like a sprite, or no, not sprite based, but vector based UI, then it becomes a little bit more fun. Okay, generate terrain data. So in terrain base we want to do terrain patches. We do, instead of set terrain data here, we do generate terrain data. Yeah, so like if you try and do a UI with vector graphics, so like infinitely scalable, like I would say using, what is it, shapes is one package for Unity by Freya, I think. I haven't dabbled much in it myself though, but I plan to. Okay, so if we do generate terrain data here, if everything goes according to plan, we should not see seams, because the one thing we will see. No, we won't. Let's see, I need to think about this. So generate terrain data creates a new terrain data with no texture. So we're at, so here we use Perlin noise texture generator. We only send in width and height. Here we have a problem though. So all of these textures, independent on world space, is going to be use the same coordinates here. So when we do get Perlin noise value here, we do width and height. Which means that yeah, we're gonna get seams, because when we generate neighboring, yeah, basically what we do is we generate a texture like this, and we use, so for this patch coordinate here, we use the same coordinates as this one. So we might want to work with origin here. We want to offset this one. So we should do public Perlin noise generator int width, int height, and finally vector2 offset, I guess. Isn't it like this, or what am I missing? Add this instead. Okay. Can we do? Yeah. Here we want to send in, do we want to create Perlin noise coordinates? We have periodic true, something like that. And then we want to rely on this one because we want to send in an offset. So back in terrain here, Perlin noise texture generator, we also want to send in, an offset here. What a mess this is starting to be. Okay, and so height rate, range and generation offset, although terrain base, generate terrain data. We want to send in, is it transform dot position? No, not really. Or is it? I think it is. But so it will look something like okay, that should be it. So before I try it, I just want to go through what happens now. So we have terrain base, everything is the same apart from this line here. So instead of doing set terrain data here, we just do generate terrain data. Generate terrain data, create a new terrain data container based on resolution, height range, and an offset. Using the width, height, and generation offset, we create a Perlin noise texture generator, and we get the texture from that one when we set the terrain data, instead of doing new data, set terrain data, new data. So a lot of the logic is within the constructor here. We set periodic to be periodic, we create new channel coordinates, all of them have the same. Yeah, we want to fix this one as well. Offset, but it's offset first. Like there. So we create new periodic or not Perlin noise coordinates with an offset. So that's the channel coordinates. Perlin noise coordinates with an origin and periodic. We set the origin here. Periodic is equal to periodic. And if periodic is equal to false, we get non-periodic Perlin noise value, which is this one, and this one uses origin here. Should be it. Ooh, is that so? So do you need to have something like this? Or I guess that would look like yeah. Oh, actually, it was not here, it was rather here. Was it? Perlin noise texture generator. What did I rely on? Oh yeah, we relied on setting those here. That's true. Okay. I tried to do this in such a way that it wouldn't screw up these ones, but unfortunately it seems to be the case. But actually we should have channel coordinates. Here we have it. So for which one don't we have it? Oh. So ground 22. Set texture in material. Okay, so we don't get one of these. Because... I wonder if we can do public Perlin noise coordinates. This true? If I do, I want to check if get periodic. Maybe this is how we should solve periodic false by default. Okay. No errors. I hope. So, environment here, terrain base. Should handle everything, and we should be seeing a sync between height maps. I'm still a little bit worried about it, but let's see what kind of result we have. Okay, yeah, I think I know why. Okay, we've generated at least. I wonder if, value multiplier has a default value of 0 here, which I don't know why I set it to that, but like every Perlin noise value we get, we multiply by value multiplier. So yeah, maybe a default value of 1 is better here. Probably. Okay. Okay, let's take a look at the chain again. Terrain base. We call generate. We create terrain patches. We create a new set layer, set material, generate terrain data with a height range. Height range is 0 and 2. New terrain data is equal to terrain data container. We use the same height range, and the offset here is position X and position Z in world space. Because, let's take a look. We created here position, yeah. So we do have an offset. Perly noise texture generator, we create a new one, but we call the constructor with height, generation, offset, and false to periodic. And then we also call set terrain data. With this noise texture here. We do it the exact... Ooh. This one. We don't do this one. Seamless indeed. Yeah, at least we have seamless terrain. So, height range is still 0, 0 when we call this constructor. That's not good. Yeah, let's see if that was the only mistake. Oof, I see so many things I don't like here. So we don't have seamless generation anymore, and we have... What the fuck is going on here? Interesting. Although the normal seems to generate correctly. Okay, this one is rough. I don't even know where to begin here. So for one patch here we have a little bit of a circle. Ooh, is the scale... Yeah, the scale might be screwed up, but still. Could the scale fuck up the terrain data container, Perly noise texture generator? Scale is 1. Yeah, okay, this one is old as well. Yeah, we might wanna... Let's see here. We calculate the coordinates. We have a period here as well. We do math F Perly noise here. Yeah, let's go with noise there as well. And we want to do all of this. Yeah, Perly noise at least when we get it from this one, it's between -1 and 1. Oh yeah. Yes, we basically want to do this here as well. But we want to do p-noise coordinates. Yes, let's take a look at this. P-noise unity mathematics. Yeah, this is periodic noise. I guess what we want is C noise, classic Perlin noise, non-periodic. Float 2. C noise. And classic Perlin noise, I want to check. Yeah, these one don't state that the value is between -1 and 1, but I remember correctly that p-noise is that way, so I think c-noise is that as well, and that's why we do this one. Still, yeah, okay, that explains it, I think. Let's see what we get with these changes. I'm still quite worried that we don't get the... Oh, I know why we don't get the... why we'll still get a seam as well. I think I know one reason for it. Yeah, okay, scale 1 is way too big. But I want to fix the first issue first with the... Or actually... this one. Okay, let's just hard code it for now. So what do we have? Origin. See what kind of value or result we get with 10 here. And yeah, I know why we don't get seamless as well. I think. Actually, this looks to be more... This does... Okay, I don't know why we're not getting seamless. Are we taking the offset into account? I think we are. Or actually, let's take a look. Okay, we don't generate the same. We're using the same height data at least. And this difference here seems to be too big to just be one coordinate away from each other. Checked if they align with the opposite chunk. So if we do, that would suck. So you mean if we go to what is it? Plus 64 plus 64. Nope, indeed. Okay, first of all, let's replace this one by vector 2.0. So if we don't have any offset, all of these should be generated the same. We'll double check if that is the case. Yeah, okay, so the offset seems to be incorrect, I would say. And yeah, so right now the offset is just a position, I think, or generate terrain data. Yeah, the offset is transform position X and transform position Z in world space. Okay, so when we get the coordinate we use for Perlin noise, so this is position in world space, position X in world space, and position Z in world space, I think, yes. And then U and V are only I divided by noise texture height and J divided by noise texture width. So for each patch, U and V goes from 0 to 1. Can you check if they align perfectly by not taking into consideration the world space? Yeah, I think we did that. We did do, let's see here, terrain patch. So we one sec. I think we changed this offset to vector 2 0 if I remember correctly, or we changed it. Did we change it here? So we did vector 2 0 here, I think. If that's what you mean. So when we generate the patches now, we do it for, we basically only rely on U and V, which is goes between 0 and 1. So it's just going to go between 0 and 1 for each of the patches. So now if we take this one and we do -64, we have them overlapping each other and they are exactly the same. So the problem is with the offset here, or like the offset might be set correctly, but I might be overlooking something. Yeah, I think the problem is, let's see here. Okay, if we take a look at, let's say that we have 64 times 64 chunks, and let's say that they align perfectly in world space. So that means that the center patch goes from is located at 0 0 in world space, so 0 0 0, and it goes between -32 0 and because when we create the position of the world space, we do dimension half times dimension plus I actually okay, I might have fucked this up. Let's take a look at create new. Have I position? So when we create it here, we have position, we instantiate with that position. Yeah. So where did I put? Oh yeah, here. Okay. So let's say that we generate a chunk with this dimension. Dimension, resolution are the same. But is it? Could it be that we don't take origin, we don't take scale into account when we offset by origin? That has to be it, right? So, like, the proper way to do it would be like this. Offset by origin, then add the U and V. And we should do it right. Depends on if you want origin to be included, but I think this is the correct way to do it. And I hope this was the mistake. Because what we're doing is we're offsetting it by world position, but then we don't scale that one, we just scale U and V. Fuck. But does it look... still looks pretty fucked. But then again, did we re-add the... Did we re-add the... offset? I might have done. Hopefully I didn't re-add the offset. That's what I hope. Where do we have it? But it's not here. Terrain data container. Generation of... Fuck, I did. Because this one was the one we replaced by vector 2, right? Oh, it's a mess. Let's see. Generate terrain data. This is the offset. Generation offset. Perlin noise texture generator. Offset. We create it with offset. We set origin here. But, like, this should be the correct way of doing it. We should scale the origin as well, I think. Actually, we do offset here as well. Dimension resolution. Okay, what if we do 64 dimension 64 32 16 64. Okay, so if we have this set up, we take the first one is located here. So this one has an offset of ooh, I think there's another thing we need to take into account. Or is it? Yes. Maybe. So, okay, let's go through this. When we create each patch, we offset them by half the full dimension and then add them like this. But so we do this offset, so this is an offset per patch. That's why we get the full terrain centered around zeros, around, yeah, 0, 2000 for some reason. So this one is offsetted by the full dimension, half the full dimension in the X and Z direction. But then when we generate the actual mesh as well, so in terrain patch, we do we do an offset here as well. Yeah, we do an offset here as well. So it's this offset we want as well, I think. Because then when we create the... So this the first offset is done to center all the terrain patches around the terrain base Origo. And the second offset here is done to center the mesh around its local origin. So it's just, that's why we have, if we select this one, we can see that the selection is centered in the X and Z plane. So we don't have the Origo down here. But that means that we need to take this one into the account as well when we read. Yeah, when we read the, or does it? Yeah, I think it does. So we want to offset here as well. I'm trying to... Let's see. 128, 128. Status. Let's go with a new 256. So when we draw let's just go with this. So when we draw this one, we offset them. Each terrain patch has this Origo, and it's currently this one we use to offset when we read the or when we generate the textures, and it's only this one we send in. So when we generate the textures, we go from here to here, and from here to here. So the Perlin noise coordinates we use for this one are within this sphere. So when we generate the Perlin noise coordinates for this one here, is actually this one, I think. Yeah, one more thing as well, I think. So when we generate the Perlin noise coordinates for this one, it's actually... it's for this one. So that should work without taking that offset into account. But the step size, when we get Perlin noise values, the step size should be world position. It's currently not. So we offset them by world position, and then we step through, but when we step through, it's like between 0 and 1. So world position might be extremely big. Yeah, I think that is the problem. So for this square here, we might just, when we fetch the coordinates for the Perlin noise, it might actually just be like for this square. So it's a mess. That makes me wonder if we might just want to scale these and base the scale on the resolution, I think. What I'm getting at is, oops. U and V goes between 0 and 1 thanks to these calculations here. So U, V. So U and V are always between 0 and 1, and we need to scale them. And I wonder if we want to base this scale on the world coordinate system. Origin is in world, so this one should be as well. So could it be, I'm gonna move, right now we have a scale, hard-coded scale of 10. Where do we have it here? I think we want to send in scale here as well. So instead of doing, oops, this, we want to set a scale here to be equal to we want it to be equal to dimension here, I think. Then the offset of world, the offset in world space makes more sense, I think. Yeah, because let's say that each patch here is 32 times 32. That means that we offset, this point is at minus 16, minus 16. So when we get the Perlin noise values, we do it from minus 16 initially. We do it from minus 16 plus 0 to minus 16 plus 1. And we should be doing it from, if we offset here as well, but we should be doing it from minus 16 plus 0 to minus 16 plus 16. So so right now we pretty much got the Perlin noise value for this square, and we applied it to this full one, and then when we go to this one we got it from here. I think that is why. If we do from 16 instead, we will get, for this one we will get this square, and for this one we will get this square. Could be. So let's do could be. We have scale here. We need scale here. Terrain data container. Generation offset. Generation scale, and then we need to set it as well. So we have an error here, and here we set in dimension. I think. I hope this is it. Okay, we're stuck at this again, but that could very well be because, let's do environment dimensions. What did we have here? 512. We have some variation in height. It's hard to see, so let's go environment min max 10 maybe. I'm just wondering if we fetch Perlin noise values over a very... It still looks like we are only working with planes, right? So dimension here. We haven't set it. This is a mesh. This is a mess. It's a mesh as well though. But... So this value is 0 because we haven't instantiated it. That's weird. Or never mind. No, we instantiated here. It should be set. Yeah, would love to be able to simplify it. Let's see. I wonder why we get just a plane from this one. Okay, let's see. Yeah, this is weird. So changing the scale here, I just need to check. Perlin noise generating dimension here. If we do 10 here again. Alright, skull tag. Okay, so if we had 10 here, we got some terrain, but it wasn't synced, or the seams wasn't synced. Yeah, okay, beautiful. So this is what I find to be very weird. So we set the scale to be equal to dimension, which for the only thing we change is we set the dimension to be, instead of 10, we set it to what is it? 64 or 512. Let's see. 512 divided by 2 to the power 3, 8. So the dimensions are 64. Is that too big? Okay, so if we do, what kind of result do we get by 128, 128, and we go back and set this one to be dimension. So now dimension is 16. Instead of 10, we have a dimension at 16. But, okay. I need to print this dimension, I think. We do instantiate it here, however. Dimension subdivided. Hmm. Ten works. Width and height here, what do we set onto? Resolution. Yeah, that's the correct one. Ten gives a varying result, 16 does not. So what is it that makes U and V are equal to width and height? I'm gonna get to the bottom of this, but before I do, I just need to run and grab something to eat real quick. So be right back, 5 minutes. back. Sorry about that. Okay, so basically what I want to achieve here is that I want each vertex making up the terrain to, or I want to fetch a Perlin noise value for each vertex making up a terrain's world position. That's basically what we want to do. And that should work. We're almost there by doing, let's see here. Terrain patch, create new terrain patch with position, dimension, resolution and transform. And this one calls instantiate here, which fetches the proper components and then sets position, dimension, resolution and so on. So when we get to this stage, we have already set all of those things per patch. So it shouldn't be a problem doing resolution, height range, and then we have the position here, but we also want to make it such that UV yes, we want to remove minus half the dimension as well, so it would look something like where do we have it? Generate terrain data, new vertex 2. Would like to do minus 0.5 f times dimension. And I want to do it here as well. So doing this means that we get the world position at so for this patch, the offset to the Perlin noise is, okay, it's at 0, 0 by default, and then we do transform position X, which brings us to here, or here, and then transform position Z, which brings us to here. So that's this and this. Then we do minus half the dimension as well, which brings us down to this. And then per vertex we're gonna loop through these here when we generate the noise. And one step here is or the full step we want to do is dimension, so that's why we send in dimension as scale. So let's take a look at what happens with these values. Texture width, texture height. This offset here is the offset, so we're down here with this one. Generation scale is this full width, and then we generate this value in here. Let's see, offset and scale, Perlin noise coordinates. We just set them here because then when we get the coordinates we do. So this is down here, or here. Yeah, so this origin XY is down here. And then we do plus U in the X direction multiplied by scale. And U, we calculate U here, and that's basically just J divided by noise texture width. So goes between, it's the UV pretty much. So that's between 0 and 1. Yeah. This makes sense. We're here, by the way. So, what kind of result do we get with this? I find it to be extremely weird that we get a full plane terrain from this. And I don't understand why. Unless dimension is... I want to do this. I'm pretty sure... Are we having a... Nah, it should be okay. Ooh, could it be... Could it... Nah, it shouldn't be. What are we working with here? Dimension 16. Yeah, it's very weird. Vector 2 coordinates. Float, float, float. No sense. Or scale, like it depends on if we have any limits here. Unity, mathematics, noise. The documentation is a little bit bad, so we are gonna have to rely on this one. And we're doing C noise. This one. And this one is also very important, but that shouldn't, we already have taken this one into account. What if we do... I don't get it. When the scale variable here is equal to dimension, we don't get the correct result. If we do 10 here once again, welcome back, Fabic. How's the progress? It's pretty much at a standstill right now. I think we found the reason for the seams not working, but when trying to implement the fix, it doesn't really work. Okay, so a scale of 10, that's fine. A scale of 15, I want to try this. Like, it seems like when the scale is the same as the texture resolution, that's when we have a problem. Could that be... if this works, that is. Okay, 15 works, but as soon as it's 16, i.e. the same as the dimension, that's when we have a problem. So it must be something. Ooh, no, it should be. Or actually 16 in this case. Yeah, I think it's the correct one. Yeah. And I want to try, let's try 17 as well. So when it's 16, it seems like we're getting a value of... when it's 16, all the Perlin noise coordinates seems to be the same. That's why we get the same Perlin noise value. Or... one sec here, though. Yeah, I know. I think I know what the problem is. Maybe. No, fuck. I was wondering if it had to do with this, but no. Unless... like, if it was periodic, it could be something that we read the same value. We get the same Perlin noise value for each vertex. But... we're gonna take a look into how scale is applied. So we add scale here to Perlin noise coordinates. We have an offset, we have a scale. So once again, periodic is equal to false, so we get non-periodic. We use this method. Unless if I'm wondering if we still keep getting this method. Yeah, we are. Yeah, this is the issue, because we called this one, but this one doesn't set Perlin noise function. This one does, however, but this one just sets it to... we called this periodic here, that's true. But does this override, maybe? No, it shouldn't. I want to try, because like if we rely on this function it makes sense. Then we take origin plus u scale v scale. So we scale this to dimension, but then we say that the period is dimension. No, it should be okay, I think. But the fact still stands that... Okay, I want to try this. Anyway, let's see. Now we don't call that one. Let's just do this twice. This one is the one we call. Okay. Do I have a problem with not releasing the terrain as well? Okay, while that one loads up again, let's see. So if scale, like this shouldn't be cause of a problem. We should just get a periodic noise instead. If this one is equal to this one. But no. Okay, so if this one is called, then we jump. Still shouldn't be a problem. The problem can come from here, because if we have a dimension of 16, or we have made it so that we sync dimension and resolution, which means that this right here is pretty much equal to scale as well. Could this be a problem? I don't think so. Or actually, it yes. Okay, so the problem we have is when scale here is equal to resolution, width and height. Yeah, let me try this. So what if we do environment, we have a dimension of 256, but we represent it by a texture that is half that size. So now the dimension and resolution aren't the same. Do we still hard code terrain data container, generation scale? No, we don't. Okay. I'll still get the same. This is a very weird issue, I would say. Yeah, we don't need this one in here anymore, I don't think. Let's see. Let's remove that one. I just want to try this one thing. Like, I don't see any other logic than, like, we're getting something wrong with the periods, like the periodic generation of this noise. When scale is dimension, we get the same value for each vertex. It's extremely weird. Also interested in, okay, extremely slow as well. So basically what we do here, when we calculate U and V, we take I divided by noise texture width and height here, so which makes this one go between 0 and 1. But then we multiply it with scale as well. Scale here is the same as width and height, which brings this one, so this one should go between 0 and height. We're up here, or 0 and scale again. I don't see it. Yeah, we need to simplify this. Let's do this. Wonder if I can use, we're gonna use Perlin Noise texture generator to generate it to a texture which we have out, which we have here in the, or we're gonna make it generate its texture to a asset so we can actually see what values it's generating. Yeah. What is the quickest way to do this? Yeah, let's do this. Let's do temps. Perlin Noise Generation Tester. And here we do and we want a target. I guess we want to do, yeah, we basically want to do noise texture to target. We need that one to be a render texture. And okay, so temp target is equal to target. And then we read back. So then we want target, 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 target. That should be it, I think. And here we want to do generator is equal to, and we want to use the same one. So we want to use width, height. Ooh, it's a problem with height, offset, scale. Let's go with a 64 times 64. And we do a scale that is 64, so the same as width and height. Periodic false. And that should be it, I think. So it's important that we create this one with 64 times 64, I think. Maybe not that, but ooh. Nah, never mind. Let's disable this one as well. So hopefully we will start a little bit quicker. And then we add a texture. Actually, we want it to be a render texture. I don't know. Where do we have it? Custom render texture. Okay, so we want it as a render texture then. Okay, so this should make it a little bit easier. We can just do target. We don't do this, and we just do this. So basically, what we're going to do is this. So we have a render texture which we set in the editor. Actually, I don't want this one to be serializable as well. So we create a generator, and then in start maybe we do generate to target. So we take whatever Perlin noise generated texture we have and we put it in target, and we should get it back. And we want this one to be the target. And what did we say? 64 times 64, I think. And then we add, yeah, we need a script as well. Like that. So right now Perlin noise is pure black. Oh, actually, yeah, let's go 256, 256, 256. And let's see. Okay, a little bit shocked that it's so slow. Still. Okay, so this one should have run. And what do we have? Yeah, it's pure gray basically. But so then to the test again. If we change this one to not be equal to the width and height, let's say 16. I wonder if we have a lot of garbage hanging around from the native array that never gets cleaned up. Definitely need to look into that. We create a lot of textures, but those should be disposed of correctly. Yeah, and then it works. So this just tells me that, okay, as soon as width and height are the same as scale here, we have a problem. Which I thought it was. Like the big question is why? Why? We don't have any offset right now. It's just 0. So basically what we're calculating here, if we just move the scaling, if we don't have any scaling here, I'm just trying to figure out, so it's pretty much J divided by noise texture width multiplied by noise texture width, which just gives us this. So going from 0 to noise texture height. Yes. No. Welcome back, Skulltag. We currently have simplified it quite a lot. Now we just check this. We have a pearly noise texture. Like the problem is that when the scale here is the same as noise texture height and width, we just get pure white noise, which is, so we must have a multiplication or for some reason it seems that the coordinates becomes the same, and I don't know why. Let's do this actually. probably know why. Oh, I'm listening. Because this is definitely flying me by right now. I thought it was something to like periodic, like we get the same because the parameters you give to the unity Perlin noise function will give different results between 0 and 1. Yeah, that was what I also was wondering. You're probably correct. So UVs needs to be between 0 and 1. You're probably correct. Because what we give... Yeah, what we have now is... Yeah, okay, I get it. So having a scale that's similar as this one just gives us whole number UVs, which means that we're always at the start or the end. Yeah, that's probably correct. So appreciate it. I'm pretty sure you are entirely correct. But then again, I wish the documentation here would say it. If we compare to MathF Perlin noise unity, yeah. So the question then becomes, we want to, since it's like a UV, yeah. So then we want to pretty much clamp this value here between that would pretty much make okay, so an easy fix here could be to do yeah, so it's repeating. Yeah, it makes sense. It makes sense. Now, like, we want to take, clamping is the wrong word. What we want to do is we want to do a remap here. So we want to be able to tell Perlin noise coordinates like the guess we would like to do it here. So now it's just a problem of I'm trying to figure out how I want this to be in my code. Yeah, like we want to normalize these coordinates basically. So this one needs to know the minimum and maximum value. So I think we can do, let's do value bounds. For now, let's do field. Actually, I think we can set this one as a range. Origin scale. Let's just try this real quick. Get non-periodic. Basically what we want to do is, I like the idea of origin and U and V. Okay, so that's bad naming, but no, it's not. So U and V here are always between 0 and 1. So then what we would like to do is coordinate dot inverse lerp. So as long as we define these correctly, this should inverse lerp to 0 and 1. Ooh, that is true as well, Skulltag, because if the width is 128, you want to start, yes. This inverse lerp should fix that problem. And let's remove that one. So now this should force this one for this one to be between 0 and 1. Now we just need to enter these somewhere. So terrain data container. Did I screw something up here? Oh yeah. Periodic, here we want to enter scale. Generation scale, range. I need to go through all of this and clean it up later on. Coordinate. What did we call it? Coordinate range. And then finally terrain patch here. Coordinate range. Oof. Let's just put it here for now. Max die. And max dimension, we want that one to be okay. I still know one error. I want to see if this still works. But so basically what we do now is when we generate the terrain data, we send in the full dimension of the terrain. And that full dimension is used to normalize the coordinates when we generate Berlin noise. It's a mess, but so basically we can try it. Yeah, we can try it real quick here by doing new range 0 2 5 6. Yeah, we need to properly dispose this one later on as well. Okay, so what error did we get? Okay, let's take a look at our Berlin noise generated here. Yeah, this one works. Our terrain does not. Okay, so that's good. This test, we have a texture of 256 times 256. We normalize it to this range, and that works. Oh, that's true. Yes. Okay. Okay. And I know why we're getting these. So these seems to be yeah, I think I know why. Because currently, yeah, what we want to do is, you're entirely correct, Skulltag, yes. What we want to do is terrain base, when we say dimension here, we actually want it to be okay, so terrain patch, we don't want it to go from 0 to max dimension. We want it to go from 0.5 minus 0.5 times max dimension to 0.5 times max dimension. So when we had coordinates that were below 0, they just got clamped to 0. I might know why we still don't get the correct values here. But okay, now we have generated terrain at least. Yeah, it looks pretty good. If you don't focus on the gaps here. Okay, this is good. But this still means that we're not getting the correct values at... We don't use the same coordinates for the vertices at the same position. And I wonder if that's because of the offset. Dashing Duo Gaming, what's up? Yeah, long time no see. How are you doing these days? Yeah, the progress is moving forward at least. So one last thing I want to fix here, terrain patch. I want to see if this could be the cause of it. Generate terrain. Actually, it's not. This is probably, yeah. So skull tag, the problem we're seeing now, I'm pretty sure, yes. We need to divide by noise texture with -1 here. But because currently the UVs only go from 0 to noise extra width. I'm pretty sure. So it goes between 0 and 0.999 or something like that. But by doing this, we will always end on 1. That's right. And then I'm gonna have to mess it up even more because we want to be able to control the scale even more. It's like the code base here is a mess. Fabric, great job. You have to start somewhere. Yes, indeed. Well, who thought it would work in the first place anyway? Yeah, same. Okay, here we go. Like, that's a good quote. Now we have it. No seams, normals working, generating from Perlin noise texture. Great. The code base is a mess, but we can clean that up. And also, the terraforming needs to be shifted one way, I think. Yeah, we need to fix this one as well. There's still a lot of things to do, but okay. What the hell to do about this code base? Skulltag, how long would you have been stuck on the -1? Well, the -1 problem is still quite fresh in my head. Like from other things concerning the terrain. But I would have guessed 20 minutes maybe. So. I'm being optimistic. So, the thing is, the thing is that we want to multiply with one more scale here. I think. So for instance, we would like to be able to add we would like our terrain to vary a bit more. So let's try what kind of result we get with 10 here. The mesh becoming invisible, that is because we don't calculate the bounds. I'm pretty sure the bounds are wrong for the mesh. So it gets cold. I'm pretty sure. Ooh, fuck me. The normals are still fucked. The normals are still fucked. Why? Why? Oh, why? A little bit fucked, but they don't seem to be. Yeah, but I thought we had the normals at the edges calculated correctly right now. Yeah, we do. We could do... Yeah, we do. Yeah, we do. Okay, one of these values are not correct. I wonder. Yeah, can't rely on Unity, not when we have patches. And we also experimented with a lot of like calculating normals on the GPU and stuff like that. The first thing I did today was to fix the normal calculations. It's a lot of back and forth, but it's this problem right here. Get index wrapped. So that get index wrapped method, this was the first method I fixed today. Unfortunately, it doesn't seem like I fixed it properly. Is the problem visible only on the top edge of the patch because it looks... Ooh, I wonder... we have the problem here. Yeah, we don't seem to have the problem... Do we only have the problem in the X direction? If so... Ooh, yeah. It looks... Yes, yes! Great catch, Fabic. Great catch. Good catch. Because, yeah, we fixed the index wrapped in the beginning of this stream, but forgot the Y, so it should be okay now. Quote, unquote, fixed. Yes, indeed. We fixed it in one direction. There we go. Okay, great. Jesus. Great catch indeed. Okay, normal's working. Patch seems working. But with a fucked up code base, but that's okay. We can clean it up. Okay, this is great. Yeah, so I just want to go through again how we fixed it. So get index wrapped was previously we didn't have these offsets here. So this is basically how it looked before. So if X is equal or bigger than resolution, subtract resolution, which makes X wrapped. So if it's equal to resolution or bigger, subtract resolution, which means that, so if X is resolution, X wrapped is 0, because, yeah, we wrap it around. The problem though, now is that when we made the height maps like this edge of this height map here is the same as this one here, because we want them synced, right, with the positioning. But that means that when we go below 0 here and we wrap around, we take the end index, so we end up here, which means that it's the same value. Like, so we wanted to go one step further. So instead of wrapping around, we wanted to wrap around and subtract 1. Or if we wrap around the other direction, so if we're here, what are these? 16 times 16. So if we have an index of 16 and we want to go to the right, we don't want to wrap around to 0. We actually want to wrap around to 1. Otherwise, we would just get the same value again. So yeah. Okay, great. Love it. Love it. And now when we handle the terrain generation, instead of generating a height map in an external software and putting it in Unity, we actually get the duplicated values in the height map, so we pretty much don't need to do anything when it comes to the edges. Everything is handled by itself. So the big task now is to get the terraforming working, but it should be okay. Although our terraforming is shifted a tiny bit right now, so if we take a look here, if I terraform this part right here, we're not gonna get a terraforming in this square, or we're gonna get terraformed but offsetted one step in the X direction and one step in the Y direction, and not offsetted but extended pretty much. So yeah, but I think I know the reason for that. So as I mentioned earlier, the initial solution to the terrain was to generate vertices at each intersection of the height maps, which meant that we had one more vertex in the X and Z direction than the height map had pixels. We changed that, but the terraform algorithm, or the algorithm for getting the points to terraform, has not taken this into account yet. So if we go to terrain patch, and then we have a function here that is alter terrain height texture within circle. Here we do grid points getter, set get index rect containing circle. We send in a lot of information, so resolution of the grid, delta of the grid, offset of the grid. In object space. Yeah, and then we use these to alter the terrain. And right now we just set the terrain at the altered place to 0, 0, 0. But if we jump into this method here we do this one is still okay. I think the clamping we're doing here is wrong. I wonder though. It could also be when we send in the rect here. Yeah, this is probably more it. Less than or equal to rect height. So I think it's both this and we want to clamp it better here also. So grid size, this is the full size of the grid. But remember, now we don't go from 0 to grid size, we go from 0 to grid size minus 1. So I'm pretty sure that this one will result in a... This might be the cause of an error. Runtime error. While... Yeah, this one just... So basically this one is the cause of the runtime error. Let's see here. Yeah, this is a failsafe, so we don't go outside of the patch, which we now do, and this one tells how many pixels we should alter. So we always alter 1 pixel too much, I think. Okay, I want to try one thing before we do any changes. So we should see an error. If I go to an edge, maybe. Yeah, let's do it here. Okay, so right where we're standing, this is where we have 4 patches meeting. So if I do terraform here, we should see a runtime error, I think. Okay, never mind. Why don't we? I would have loved to see a runtime error. Yeah. Well, actually, never mind. Never mind. Yeah, so what's happening here is, let's take a look. I wonder if, yeah, we do yeah, when we call getPixel, I think this one works with the wrap method, or that's the only reason I could think of. So if we do getPixel with a too big, we should, that's the only reason I could see this one working. I want to try and do wrap. Repeat, I mean. I want to see what happens if we take repeat here and try to do the same terraforming. I wonder if we will get the opposite edges to change. I want to make this make sense before I start quote unquote fixing it. So if we do this, yeah, okay, yes. So when we go outside of the bounds, thanks to getPixel and setPixel, we just wrap around, so we alter on this side as well. We couldn't see this previously because we had wrap mode clamp, so we went outside of the bounds and pretty much changed no pixels, or just the pixels we already changed. Great. And the idea is to let get index rect containing circle. This one should clamp these already, so we shouldn't have to worry about this, because the idea is to do this in a very much a way more optimized way, but that optimized way is less secure. So we want to make sure that the indices we give it are within the texture. So grid size, we want to clamp between 0 and grid size -1, I think, because let's take a look at what grid size actually is. Grid size is resolution, and when we generate, like, so the texture has a resolution of 256, i.e. indices going from 0 to 255, and we only have vertices for 0 to 255. But let's see. Yeah, so this is where we change the height map, then we call update vertex data within circle, and this is where we actually recalculate the vertices. And when we recalculate the vertices, we just go within resolution. Or we recalculate all of them. Yeah, we want to do this in the future, but right now we recalculate all the vertices. Okay, it's a mess. It's a mess. But first of all, grid point together. That should make sure that we don't go outside of the patch in question. Terrain data container, and I think we just want to do this. Wrap mode did I... Yeah, we still have repeat here. Yeah, good. Let's try it with repeat, see how it looks. So that was not good. Okay, we don't repeat anymore, so one issue is fixed. Although I wonder... Yeah, which means that we should probably go like this. We still have a problem, I think, of let's change the environment so we can test this more. So 0 and 2. Attempting to divide by 0, that's not good. Oh, I know one more thing as well. This grid actually locks on to vertices. Or not vertices, but the grid delta, which means that it is... It's better to see it down here, I think. I thought it has a weird offset. But for a couple of reasons, I think. Yeah, it seems to be a scaling issue. First of all, let's take a look. So one issue is, let's see here, action terraform. You added additional scale to, I think my shaders should take it into account. Let's see. So this is where we set a lot of the variables. So terraform visual point material sets the terrain delta here, which it gets from the terrain. Yeah, I think it's only terrain delta we need from the terrain, but update terraform point here. We currently truncate this value to terrain delta, which means that the marker will be locked onto like the intersections, I think. So the marker locks onto these points instead of, so previously, why can't I paint? What the hell? Okay, so previously we worked with these intersections, right? Right now we work with the middle of the pixels. So this is one issue. Our marker snaps to these points, and we want it to snap to these points. Can you set the added scale to 1 and see if they're, like, I think, let's take a look here. Environment, terrain, base, we have dimension, resolution and subdivision constant. These we can change. The only relevant one for the marker, we can definitely see that the scale seems to be wrong as well. Yeah, I think we have multiple things that are off here. But I think we currently relay all the correct information. Actually, let's take a look. World position grid error. Grid delta we correctly set. I'm pretty certain that we do. Yeah, grid delta is 1 right now. This is weird. Scale, I should be okay. Yeah, but it sure does look wrong. Okay, this is weird. So in the X direction, ooh, this is interesting. I have screwed up somewhere. So in the X direction, or have I? Yes, okay. I know what the problem is now. So once again, it's the changing from, let's see here, action. Oh shit, this is a mess. So if we go to terrain patch, this one is okay, I think. Or actually, do we want it? Yeah, we want to change it so it's dimension divided by resolution 1, right? So this is one issue. But then again, I wonder... Fabric, no. As soon as something comes to mind, just say it. So it's okay. And yeah, we can set it to orthographic, but I'm pretty sure we got the scaling on the delta a little bit wrong here, or I hope that's the issue, or that's one of the issues. Action terraform, what do we actually get this from? Environment controller terrain delta. Yeah, okay, so we need to terrain base, there we go, delta. Yeah, like it has been a lot of back and forth here, I would say, but so should it go from 0 to resolution or from 0 to resolution -1? So we might have some... there's probably exist a few places where this has not changed, and this was one of them. Now I think the scale should be correct, but I'm going to show you another problem as well. What the fuck? I was pretty damn sure that this would fix it. Am I thinking about it? Or actually, am I... Dimension divided by delta. It should be dimension divided by delta, correct? Or resolution. This is the correct delta, isn't it? So how big is your whole terrain size in patches? I think it's 8 times 8 currently. The worst part is that it seems to offset a tiny bit per so we can see here that the offset becomes smaller and smaller, or bigger and bigger. But okay, that's never mind. If we do I'm pretty sure it has to do with the delta. I'm just like, one of these has the wrong delta. I think we can do so it's tiny delta error we get. So one of them has a smaller delta. I wonder, let's take a look. Okay, so here we can see that the marker has a delta that is a tiny bit smaller, which I find to be very weird, since we're going from or like we're fetching the delta from the terrain itself. So does the offset vary from the circle center? I think we can see it here. Like right now, I just want to try, let's do this. Sphere, do we have grid delta is 0.9 or 1.1? 1.2. What's up, modding Minecraft? What's your dream job? This, I suppose. Otherwise, I would be out chasing it. How about you? A sheet developer, that's sad. What's the fun in cheating in multiplayer games? This has to be a grid delta error. I don't see how it could be anything else. Quote, I love playing in hacker versus hacker servers, it's kind of fun. What the fuck? So, let's see here. Let me just double check this. Environment, we have a resolution of 128. A dimension of 128. Currently we set the delta to be 1. But if we do 128 divided by 127, we get this. And if we set this one here, then we do get the correct one, right? No, we don't. 128 divided by 129. So let's see here. I wonder if it's the actual The bigger the circle, the bigger the offset. Ooh, maybe. It seems to be. Like the bottom line is that one quad of the terrain doesn't match the size of one quad in the visual grid tool we have, and that's why we get the offset. First of all, I think do we have the correct? Let's take this one and let's add a cube, and let's see here. Okay, so it's located at 0, 0, 0 for this one. So 16, 16. Okay, so we have the correct size here. Our patches are 16 times 16, and we have 15 times fuck me. We get 15 times 15 squares. That's not correct. I want 15. I want 16 times 16 squares. Did I mess this up once again? Yeah, that's not good. We want them to sync, I think. Or actually, yeah, this is not good. Yeah, I know. I might have thought about it wrong. So yes, we removed the +1 at the beginning of the stream, but that might have been the wrong decision. Definitely. Or actually, no. We want the same number of vertices as we have. Okay. Yeah, we want the same number of vertices as we have pixels in the height map. So let's see if I can wrap my head around this. And we currently have that, so that's good. So it's 16 times 16 vertices, but that becomes 15 times 15 squares, but that's okay, as long as the texture in question is 16 times 16 as well, which I think it is. Terrain patch. So you have 16 meters, 15 div, and 16 verts. Yeah. So it's the delta we need to take into account. I just need to make sure that the textures are actually 16 times 16. I want my textures to be 16 times 16. Let's see. The idea was to make, exactly, the idea was to make, let's see here, the length of this one Yeah, we just have to take this into account on grid delta, I suppose. Yeah, okay. So the delta here, is this one correct? What a mess this is. Dimension divided by resolution. Yeah, it should be correct. Delta should be correct here, right? Because we're going... these sizes match and it's 16 here. We should get a delta of 1 and I think that's correct, right? Or actually, is it? 1, 2, 3... So if we do cube 1, 1, here we have the problem. The delta is not 1, but rather, which size do we have here? 128 divided by 8, 16. So we have 16 divided by 15. Can I copy this one? And that should be correct, right? Yeah. So yes, the delta is wrong because we want to take 16 divided by -1. So if we go to a terrain patch and we calculate delta like this, that's wrong. We want to do resolution -1, which I thought we could do. But the problem I did was to assume that here we have dimension -1 here as well. I don't think this holds. No, it does not. Right. Here we want to do dimension divided by resolution minus... Or actually... Because this is the delta that the shader uses. But I wonder if we want to take... So here we want to have subdivision, exact. So something similar to what you touched on, Fabic, right? That has to be it. I'm pretty sure. So we should take resolution minus... Is it -1 per subdivision? But we want subdivision, not subdivision count, so let's do... delta. We want to set delta around here, I think. Dimension subdivided resolution subdivided delta is equal to dimension divided by resolution minus subdivision. Is this the correct? Maybe. So yeah, does it look like an offset of 1/8? That was, if this is correct, that was pretty damn spot on. I'm a little bit worried though that we got the correct, semi-correct normals, it looked like. Hell yeah, here we go. Beautiful. Great catch, Fabic. Okay, beautiful. How does the terraforming look now? Quite big still. It looks to be pretty good, I think. Or actually, do we alter more than we want? Maybe we do. Yeah, this is the problem we have. Not gonna lie, I'm learning so much from your stream. Nice, happy to hear, happy to hear. So the problem we get a problem when we terraform. Yeah, okay. When we terraform right at the edge, we don't get a sync between Okay, that's unfortunate. I want to double check one thing here. The problem could possibly be, where do we have our sphere? Yeah, our sphere doesn't touch this one, although yes, we want to offset the sphere. Right now the sphere has the size of, it's located on a pixel. Pixel here, okay. Yeah, okay, so the problem is, yeah, so we do an overlap sphere here. So we take all the terrain patches within the sphere. So currently that's only this one. Although if we would have done a, but we do include this and this. So we have two options here. Minimize the radius, like either when we do overlap sphere, we make it a little bit bigger so we get the other terrain patches, but it still looks like we go a little bit step too far. Let's see here. Can you check if you're editing the first? Yeah, exactly. That is one solution we can definitely make, but that involves a lot of branches and stuff like that. So that puts, it's gonna be a mess to implement. I think we can hack this in a acceptable way by doing the overlap sphere a little bit bigger than we should be getting it. But like when we do physics overlap sphere, we add half the delta as well, so we get neighboring patches. But I wonder if a better option might be now we're getting pretty close to how we actually like the visuals of this one. Like what I'm seeing right now, if we go in game, if I saw this grid in game, I wouldn't assume that this vertex would get altered, right? We altered this one because it's clearly visible. This one is barely visible. So if I was playing this game, I would assume that this vertex was to be left unaltered. But right now this one alters this one as well. So what we probably want to do is the radius of the circle also snaps to delta, so we can only change the radius of the sphere by 1 delta at all times. But so I would actually like to go in the direction of I think when we create I think the way I want to go here is I want to clamp this one by, or not clamp this one, but here we do grid offset plus divided by grid delta. I wonder if we want to do this one. I wonder if we want to, I think we want to subtract this one by 1. Okay, that should be good. So adding a small amount to the radius should do the job. Yeah, I agree. Like, the two quickest solutions to this one, without getting into the code and checking if neighbors has been altered, we could either make this sphere a tiny bit bigger, or like the overlap sphere. So when we check for terrain patches, we make this one a little bit bigger, or or actually, yes. Yeah. When it all comes down to it, what needs to be changed is we need a little bit of an offset between we can't let the radius of this sphere be the exact same as the radius of indices we're going to change. It's just a question of once again gameplay. Like if I saw this grid in a terraforming related way, I would assume that only this, and this vertex changed. So but that's not the case right now, so I wonder if we want to do this. Yeah, I think we're gonna do so we have, if we have something like, the idea later on is to maybe fade it out a bit more. So like right now the brush we're using are just affecting all vertices equal. The idea is to in the center affect it the most and then less and less. But I think we're gonna do it this way. So if we go to the action terraform here, and right now we have terraform point radius. So this one, this should be the one affecting the actual terrain, while we should be adding an offset to here, so scaling the visual pointer. And the scale to the visual pointer, like this one here, when we do overlap sphere, terraform point radius, this one should take the offset into account as well. So terraform point radius, this is the one we're gonna send in here, because it's the one that matters the most. But when we do overlap sphere, we're gonna add an extra size here, and we're also gonna add an extra size to the visual one here, I think. So we can do terraform point radius. Where do we have? Whoa, whoa, whoa. Have I misspelled? Terraform point radius. Ah, okay, that is. Here we go. Terraform point radius. And I wonder if we want a. Maybe. Terraform point radius offset, or no, error margin. And this one, we're gonna set this one to be I wonder. Terraform error. We're gonna set it here, and it's going to be equal to 0.5f terrain delta, I think. Something like that. Oh yeah, and then we want to use it. So when we update the visual sphere, update this one. We want to do terraform visual point like this, and then we also want to do overlap sphere here. I think. Exactly, yes. I think this should work. And this should communicate to the player better which vertices that will change, depending on the brush, but... So changing here changes, okay. Yeah, these four. Okay, here we have an issue. I wonder... Can't divide by 0. Did we get it here? Yeah, okay. I'm interested in this error, but yes, okay. With this marker we actually change more as well. So with this one we do change these. Let me see if this works. Yeah, we changed one more than we should, or which I would assume. Yeah, the grid is still not communicating entirely what it actually wants. Let's see. I wonder. Sphere radius. Yeah, okay, the radius here is sphere radius. Still. Yeah, okay, yeah. So here we also want to add the .terraform error margin. Okay, but let's see here. We still have one issue here. Attempt to divide by 0. That's not good. Terrain data container 54. Okay, so if rect width is 0, Whoa. Yeah, this is not what we want to do. I'm pretty sure. Oh, it is. Brush texture, or actually, no, it's brush texture dot width we want to do there. Or no, it's not. It is rect width, but we need to make it work when it's 0. Yes, I need to think about this one. So this happens, I think, when we try to alter a. We have the marker between two patches, but it's so far away from one of them that only one vertex gets included in the rect width here. So we basically have a, I think, yeah, x start and x end becomes the same. Yes. Ooh. Yes. Okay, so I guess so. Let's assume that we have our marker here, including this vertex. So for this patch, we will get a rect here, which has the same x start and x end, which includes this pixel here. And that's not correct. So I think we want to do when we get this one, we want to do a rect that starts here and have a size of 1. Alright, Fabic, thank you as always for stopping by and with the input. Appreciated, much appreciated. Have a great rest of the day. Okay. So how do I actually want this rectangle to be created here? So we should have this start point, definitely. But if you go the size of 1... Ooh. This is not entirely correct. Get pixel by linear. No. Or is it? No. So when we get the pixel from the brush, pretty much what we want to do here is we want to transform a index. We want to transform an index from world space or patch space into a index in brush space. That is rough. Okay, so this is very dependent on basically the brush depends on the origin and the size of this one. So let's say that we have a brush like this. So this is the brush texture and we want to let's go with a brush texture like this. So we want information from I guess it's the radius we want to take into account here. So radius are actually divided by So this pixel, when we paint this one here, it should have a brush UV of 0. It should have a brush UV of 1, 0.5. This one should have 0 and 0.5. So it's the radius we want to take. Or is it 0.5? Yeah, the index divided by radius. So we're down here. This is 0, 0. Radius 2 times radius. Okay, so it's the diameter. The diameter of the marker. We need to use that one to properly get the texture UV, I think. So for here we take the rect index divided by radius or diameter, get 0, 0. And we got 1, 1. 1. That's not true. Is it? Okay, so we loop through this rectangle. That is the most important part. We start at 0, 0, so 1, 0, 2, 0. Yeah, so what we need is, inside of here, we need alter terrain data. It's not enough with just a rectangle, I don't think. We also need terrain patch. Where do we have these methods? Alter probably gonna start tomorrow's stream with cleaning this mess up. Here we go. The fuck? Before instantiate. That's pretty weird. Okay. Yeah, we need a diameter in index space. So if the radius covers 2 indices, that means that the diameter is 4 indices, and that's the one we need. But then again, that's not entirely true. Because, okay, so if we take a look at this rectangle there. Okay, so for this terrain patch, this is the rectangle we have. For this terrain patch, however, the rectangle we get is this one. So if we have a point here, then we get this is rough. We get this rectangle for this patch, and for this patch here we get, it's hard to draw, but basically this rectangle. The red one. The white one is straightforward. The red one is the one we're having problems with, because this one only has it's a 0 times 2 rectangle. So it's a question of like this rectangle here. Yeah, what we're gonna do is to do create custom rectangle or marker struct containing the rect both as indice based. Oh, let's see here. Index, world space, and marker relative. Containing the rect both as index, world space, and marker relative. Defined. I don't know. Maybe not the best sentence there ever was, but yeah, so that's what we're gonna do. So tomorrow let's do clean up code, yeah, and then implement custom rect struct, because we need it as index based when we're gonna change the vertices to make it quick, and we need it as, I don't want to send in more information here, like I want to pack it into one object, makes it easier to handle, I think. But unfortunately that's it for today. I gotta run, but I would say the progress was pretty damn good today. And I'm extremely happy that I don't need to manually handle edge communications when terraforming and generating from the start. So yes, thank you everybody for watching. Always appreciated, much appreciated, and have a great rest of the day. Peace.